So here in this lesson, I'll be going over problems that deal with algebra, right, utilizing the concept of limits. So this equation here states that the limit of this following function here as x approaches -3 equates to what value? And so the first step here is always to see if there are any removable discontinuities, right? If there are any factors that can cancel out, and you can simplify this so that the x plus 3 goes away. Obviously, your first step is to plug -3 into the equation, and you do that and you see that -3 plus 3 is 0. Well, that just, that anything divided by 0 is obviously undefined, and so we want to make sure that we can get a value that is not undefined, right? We want a value that is defined, so we want to somehow change this into a form when we plug -3 in, we get a value that is defined. So we can factor x squared plus x minus 6 into x plus 3 times x minus 2, right? So we can, obviously, we always want to write this limit and then x arrow -3, right? So limit of this function as x approaches -3, right? And here you know that x plus 3 cancel out, so you know that there is a removable discontinuity here. Again, that idea of a hole, right? When you want to know where your hole is located, you know that you usually whenever we have that idea of a hole, right? Whenever we're graphing rational functions, we cross out the common factors, right? And then we set one or the other factor to 0, right? And so in this case, we would get x is equal to -3, right? But because we're setting any one factor equal to 0 and then determining the value of x, so we know x is equal to -3. Then we're plugging -3 back into the equation into its simplified form, which in this case would be x minus 2. So we would see that the hole is at -3, -5, right? That's the way how we determine the whole. And really, if you think about it, when we're talking about limit of this as x approaches -3, that is talking about that specific whole, right? There's that removable discontinuity here, the one that removes when we're canceling out the factors. So you will still get this value over here. In fact, you will get -3, -5, or specifically when we're evaluating this, we will get -5, right? You cancel out the x plus 3's, right, from the numerator and the denominator, and so now you have -3, and clearly, because the x plus 3 is gone from the denominator, you can plug -3 into the equation and you will get a defined value, right? You solve this, you get -3 minus 2, right? That is equal to -5. So that for question number 58, our answer is -5. So now I have question number 59, again dealing with limits. So this one states that we have, obviously, x is approaching 0 here, so we have x minus 5 squared minus 25 all divided by x. And again, we look at this, we know this really means limit of this function as x approaches 0. Well, if x is approaching 0, this value over here is undefined, right? Because x is in the denominator. So you want to, again, change its form somehow, right? So looking at question number 59 here, we can obviously, the first thing I would do here is just expand the x minus 5 square, right? So we see that this becomes x squared. Well, you should know by now that this is just x squared minus 10x plus 25. Here's a minus 25, so they cancel out, and then you just have divided by x. And this is a good sign because our numerator can be factored out, right? We can bring this x outside. So we have x, and then we have times x minus 10 all divided by x, and clearly the x's cancel out. That's a good sign, right? Because now when we plug in x back into the equation, we don't have to worry whether we're going to get an undefined value. Obviously we're not, right? Because we have canceled out this x from the denominator, which was previously giving us an undefined value. So now we can just evaluate this by substituting 0 into the equation. And for question number 59, we should get the value of -10. So thanks for watching.